Well, hello everybody. In this question, what we are supposed to do is given the equation of the curve C and the equation of the line L, we need to show the x-coordinate of the point A is 2. So this is the point A. We need to show the x-coordinate is 2, and then the line also cuts C at the point B, and we need to verify that the x-coordinate of B is -4, and then finally we need to find the area of this region R using algebraic integration. So that's the question in summary. So to start with, we need to find the coordinate of the point A. Yes, we need to show that the coordinate of the point A, the x-coordinate is 2. So what I am going to do is, so for the part A, from the equation of the line L, so I will write from the equation of line L. So we are given the equation that is y is equal to -2x plus 7. So that is y is equal to -2x plus 7. We see that the gradient is equal to -2. So this is the fact we need to keep in mind. So I've just put a rectangle around it. So then I need to go to the equation of the curve. So equation of curve C, that is y equals x cubed minus 14x plus 23. So that is x, I should write y equals x cubed minus 14x plus 23. So I'm going to differentiate this, and then the gradient of the curve at the point A and the gradient of the line at the point A, they are equal, using that idea. So differentiating, we would get dy over dx is equal to 3x squared minus 14. Now the gradient at the point A is -2. Okay, so gradient at point A -2. Therefore, -2. So therefore, dy over dx is equal to -2, and that is equal to 3x squared minus 14. So hence we can write 3x squared minus 14 is equal to -2. Therefore, 3x squared is -2 plus 14, that is 12. So x squared is equal to 4. Therefore, x equals the square root of 4, and that this would give us x equals plus minus 2. Now, the point A being a positive x, this is a positive x, so then obviously we can say that the x coordinate is 2. So for point A, x coordinate sorry, my writing is not perfect, being positive, we get x is equal to 2. So that proves the first part, okay? To understand, the first part is done. So the point A, you would have, if I could thin my pen a bit. So point A, this is the point A, and touching the x-axis. So this would be 2. So this we can write 2. We don't know the y coordinate, okay? So we will come to that bit in a moment once. Let me look at the part B. So we need to do the part B first. We need to verify that the x coordinate of B is -4. So so then B is -4 to verify. So we can do that using the intersection of the line and the curve. And I think that's the easiest way to do it. The intersection of line and a curve. So if I were to say for part B, okay, thin down the pen a bit so it's easier to see that intersection of the line and a curve. Point B, line and curve. So then we are going to write that we have both y -2x plus 7 is equal to x cubed minus 14x plus 23. Oh, that's right. Yes. Okay, so then we can bring them all to the same side. So therefore, x cubed minus 14 plus 2, that's minus 12x, and plus 23 minus 7, 7 plus 16, 16 is equal to 0. So now we need to verify that x is equal to -4 will satisfy this equation. So then the point -4, x is -4 should be the x coordinate of B. So to verify that x equals satisfies the equation, so at x is -4, we get -4 cubed minus 12 times -4 plus 16, and that equals not, yeah, so that would be 4 times 3, so that is 16 times 4 is 64, so minus 64 plus 48 plus 16, that is equal to minus 64 plus 4, 5 and 160, that is 0. Hence x is equal to -4. Hence we have verified that x is equal to -4. So we verified it, so that completes that bit. So because it satisfies the equation, so we've written all that. So then it's verified. So hence the coordinate of B is this. Okay, so now that we have done the parts A and B, we need to find the area. Now you see for this area bit, when we integrate, So obviously this is minus 4 and this is 2. However, when you're integrating, we'll be integrating within this region, minus 4 to 2. So the area we will be getting using that integration is this entire area, because we're integrating the equation of the curve within the region minus 4 to 2. So we need to subtract this part that is the white part, which is the trapezium. So if I were to now name these points on the x-axis, if I were to say this is the point M, which is minus 4, 0, and which is the point N, which is 2, 0. So then you would see that to find the area of a trapezium, you need to find the height. So we need to find the y coordinates. So to find the y coordinates, we need to substitute the value of x, isn't it? So we need to find, if we find x is minus 4, then what is the value of y in the equation of the line? So we need to substitute. So then I change the pen color to something blue. Okay, so then I have the part C. So then substitute x is equal to, so we have 2 points. X is minus 4 and x is 2 in the equation of the line to find the y coordinates. X equals minus 4 and x equals 2. Is it 2 or did I get it wrong? Sorry to be scrolling up and down so many times. So x is minus 4 and x is 2 in the equation of the line. In the equation of the line to find y coordinates, right? So then at x equals minus 4, what would y be? So we have the equation of the line, y is minus 2x plus 7. So y is minus 2 times minus 4 plus 7 equals 8 plus 7, that is 15. So we get the coordinates of the point B is minus 4 and 15. So hence this is 15. Okay, so B is minus 4 and 15. So I'm going to write that minus 4, 15. And then x is 2, so y is minus 2 times 2 plus 7 minus 4 plus 7, that is 3. Hence the coordinate of A is 2, 3, isn't it? 2, 3. So this bit is 3, right? So we will get 2, 3. So now we can work out the area of the trapezium. So I will work out area of the trapezium. So I have a name for that trapezium and I have named it ABMN, okay? ABMN, hope it's right, or NM. So sorry if I keep scrolling up and down. Wish it was on paper, was easier. So ABMN, yes. So area of the trapezium ABMN is equal to half times the sum of the parallel sides multiplied by the distance between them. So the sum of the parallel sides is 3 plus 15, That's 18. So I will have to write 18 multiplied by the distance between them. So the distance between them is, this bit is 4 and this bit is 2. So the distance between them is 6. Times 6. So that is 2 times 3 is 6. 3 times 18 is 54. That is 54. You can see this is square units. Incorrect. So the area of the trapezium is 54 square units. So we need to bear this in mind because we will need to take off this 54 from the area of the curve, after integrating, we're going to get that. So we need to take off the 54. So now to get on to our final bit, the integration bit, integrating the area of the curve. Integrating, so within the region, so the region is going to be minus 4 to 2, okay, minus 4 to 2, and then we need to break it down again. I'll do more scrolling up and down. So it's minus 4 to 2. And what is the equation of the of this curve? The equation of this curve is x cubed minus 14x plus 23. So I'm going to write that x cubed minus 14x plus 23. That's what we have to do. So what I'm going to do is we're going to break it down. That's what is normally done. So that is equal to minus 4 to 0, x cubed minus 14x plus 23 dx, and plus 0 to 2, and then x cubed minus 14x plus 23 dx. So then we get, it's an easy integration, so that is equal to x cubed is x over 4 to the power 4 over 4 minus 14x squared over 2 plus 23x, that is minus 4 to 0, and plus the same thing, x to the power 4 over 4 minus 14x squared over 2 plus 23x, 0 to 2. So hence the first bit is being 0, so 0 minus minus 4 to the power 4 over 4 minus 2 times 7 is 14, so that's why I'm going to write 7 times minus 4 square plus 23 times minus 4. So then plus, I just have to write 2 to the power 4 over 4 minus 14, or rather minus 7 times 2 square plus 23 times 2. So I should write here to find the area under the curve to make it here. Right, find the area under the curve. So then this bit, so then what we get is from here is that is equal to, you will have minus 4 cubed, 4 times 4 16 times 4 64, then 16 times 7. So that is 112. So plus 112, and then I have plus 2 and 92, and then plus, that's 4, and then 4 times 7 is 28, so minus 28, and plus is 6, 56. And then the answer to this, let me work it out. So it's minus 64 plus 112 plus 92 plus 4 minus 28 plus 46, and I get 162. But this is not the answer. The answer is something else. And why is it something else? Because I need to subtract the area of the trapezium. So again, going back up to my question, the finite region R, area of the region R is going to be, so I am going to write area of the region R. So that is equal to 162 minus 54. And that is equal to 108. And is that the answer? Probably is. I need to check. Yes, so we got it. The area of the region R is 108. So that's what we got. The area of the region R is 108. And that completes this question.